To Shredder, Introduction to R Pipelines and rstan. I'm Jonathan Sidi. A little bit about me. I have a PhD in statistics from the Hebrew University in Jerusalem. I work at Sage Therapeutics doing modeling and simulation, and I primarily use R, Shiny, and Stan in my day-to-day work. You can find me on Twitter and on GitHub. A little bit of motivation for the talk. Within an R MCMC workflow, there's a decision point where we need to make if we want to simulate predictions in R or directly through Stan. The pros of doing it through Stan is that the model is already written and you just have to add a generated quantities chunk in order to create the posterior predictions. The downside is that disk memory can be very large for these fit objects that we're returning and heavy on our memory computations. That way we can't really do post-processing beyond the model validations because the fit object is too big. Another way to get at this would be to use R in order to simulate those predictions. That way we're using less memory for the posterior samples, but you would have to rewrite the Stan model in R script, which could be very difficult and create opportunities for human error and more QC work. Let's assume that we have a fit object that we already created. That fit object needs to service a few tasks. First and foremost, we need to validate that the model fit correctly through cross-validation, and also the parameters are behaving correctly through trace plot, r-hat, and pairs plot. Beyond those basic needs that we do, we have model-specific post-processing that we need to do usually through a project. In R, you can use tidybayes or posterior or convert the fit object to a data frame through as data frame. That is constrained to only a wide format, which can create a problematic output because you have rows that are changing in durations, and if you have predictions, then those can be very large depending on the sample size that you have. That same rectangle can be used then with tidyverse or different R packages in order to create post-processing outputs based on the posterior samples, such as forest plots, parameter tables, and in the example that I'll show, Kaplan-Meier curves for survival models. The problem that we're trying to solve is how do we marry between rstan objects and the workflows that we're used to through magrittr and pipelines that are more readable, and also that we're used to using dplyr and tidyverse with different verbs. So the workflow for people who aren't familiar with pipelines is that instead of having nested functions, you unfurl them basically, and the output that you have from one function is fed into the next function through this pipeline operator. So in this case, we're reading in the data, and that data is being used by subset as an input, and this logical expression is filtering that object. That output then is being, and columns being added to it through variable C, and the first 25 rows are being kept. So in many cases, for a large workflow, a pipeline is easier to read across multiple people, especially people who aren't that well versed in base R. Opinionated syntax is the backbone of tidyverse and dplyr, where a lot of SQL verbs were adopted into dplyr, such as select and filter, or contains, which then make it easier to manipulate data frames. This type of construct is being adopted by a lot of our users, and Shredder kind of marries between these two ideas where we want to create pipeline type of API, but also add new verbs in order to manipulate the fit object, where the idea is that the large fit object with all the post-warmup samples that we have and predictions may be too big, and we can manipulate that fit object and create smaller ones that are task specific in order to run fit diagnostic and post-processing that are more targeted in the tasks that we need to do. Using the pipe operator, we can unfurl different types of objects and then create more human-readable code. And finally, using primitive commands, we can bundle up different functions in Shredder that can be used as part of larger workflows and replicate those across workflows, making it very generalizable. Shredder can be used in rstan and brms at the moment, can be extended further with different classes, as we'll see. The Shredder workflow, in comparison to the standard workflow, you have a parent fit object. You want to do the post-processing with rstan family packages and the non-rstan family packages. So through Shredder, that same fit object is being split up into children objects, where each one of them has a task that they need to achieve. So child 4 in this case would be tasked with the post-processing of cross-validation and rhat and Paris plot. The different children that we're creating that are much smaller than the original fit object are then converted into rectangular objects, data frames, through tidybayes. And then they are specific to the task that they have to do. So one is creating a Kaplan-Meier plot, another one a force plot, parameter table. Each one has different types of parameters that are important to it, and that way we can slim down and create more specific outputs and fit objects that can be used more versatilely in the project. The current verbs in Shredder are split into two groups, subsetting and selecting, and also slicing. So first, subsetting and selecting. So stand retain will keep specific chains of the fit object. Stand names will let you query or return the names of within the stand fit object of the different parameters. Stand select and the lower level contains, starts with, and stand ends with can select specific parameters or partial parameters based on regular expressions. Reducing the object size is also very important through removing cached elements, which I'll show in the next slide more specifically through stanx. And thinning out or slicing the post-warmup samples, you can extract specific indices that may be problematic in your interrogation. Or if you just want to create toy or you're testing out different toy post-processing functions, you can thin out the full post-warmup samples and test things with smaller subsets of the fit object. Finally, there's stand filter, where it creates a very versatile environment where you can filter across the different parameters in the fit object based on a logical expression of parameters within it. So let's say we have some parameter, let's call it beta, that there's a certain area of it in the post warmup that you want to focus in on. So you can filter on that subdomain in the range of beta, and then all the other parameters will only keep the samples that answer that logical expression. So you can create either different cross-validation based on a subset, or you can create posterior predictions of a specific area of the domain, or your whole routine can be based on specific attributes of the output. StanX is primarily created for smaller stanfit objects where most of the memory is not being used to store the post-warmup samples, but it is being used in order to be able to run the stanfit object over and over again, which is built by default that way. So if you're only interested in post warmup and post-processing, you don't really need those extra objects, so you can remove them safely using stanx, such as the fit instance, the stan model, the summary. We've seen that this can reduce smaller fit objects by factors of 5, which is very important when you want to quickly iterate over different models. Example of a primitive function where we're bundling different functions of shredder is stanextract, where we're combining stan select and stan thin. So we're using the pipe operator to take a model, select specific variables using rlang verbs, and then stan thin, which is going to create a very thinned out version of the original model. And we're using tidybayes recovered types in order to inform the fit object of the different data structure that we have. That can be important for scalability. So using this kind of primitive bundled function, we can scale this across models of fit objects. So let's say you have different endpoints of interest in the model, or the same model structure by priors or different hierarchies, or the same model with different observed inputs. You can use packages such as per or fur to utilize different parallel extensions. You can create a consistent pipeline that is model agnostic to generate R-side ready outputs. So we can now strategize with greater certainty the different outputs we want to create, so we can better communicate to stakeholders the different outputs of models and comparison of different models that we're running. So here's an example of code. So we're reading in, for this example, let's say 4 different models of a survival model in Stan as hierarchical by structure. The data is read into assigned to data. Using the different fit objects, we can use the stan extract in order to pull out 4 parameters specific to this task. And that list of fit objects will be then passed through map.df, which is going to convert them all into a data frame. That data frame then can then be used to generate Kaplan-Meier plots based on the simulated survival curve. That plot is then wrapped by model, so now we're creating a construct that we can easily compare different types of model characteristics on a single visual output. So this would be an output from that function. The black line here is the observed survival curve. The hex plot behind it is that higher density means that simulated survival curves pass through that hex bin more than other areas of the plot. So you can start to gauge with higher certainty where the different survival curves passed. So here you can tell that the model is less certain about this, about the tail of the survival curve. We can also, using shredder and per, we are now able to compare the different models on the same output. This is much more efficient and flexible than the regular rstan workflow, where you have to interrogate one model at a time, and combining across different fit models is is a task that is very difficult to do. So in the same schema, let's look at the scalable workflow. So we have our 4 models that we fit, and we're using per map through shredder in order to create the children. So we're going to have a list going into per map applying shredder functions and creating a new list that is smaller and less burdensome on memory because the children are much smaller than the original parent objects. Those same children that are in a list format are then converted through tidybayes into a data frame, or more specifically a tibble with list columns, where each row is a model and each column is a child. So this is the first child of the first model, the first child of the fourth model, and so on and so forth. This is now a great way to combine and interrogate either a specific model or combine across the models in order to compare different model fit characteristics or trace plots across the models. So here we're passing through map 2, we're passing those same child models, and in the second argument, we're passing in the actual functions that we want to run. So here we're passing in a list that we want to apply to each child. We want to apply a list of all these functions. And then what we get back is one single list of the outputs each function would create. That way, we're already set up for a comparison across the different models. The other children in the tibble are then can be assigned to different predetermined post-processing activities, such as the Kaplan-Meier curve that we saw before, visual predictive checks, forest plots, and parameter tables. And everything is set up in order to be able to compare. So you can either put parameter tables side by side, or you can merge between the different outputs in order to create a single table across the fits. Shredder is also built to extend workflows, so it's not here to replace rstan, VRMS, or tidybayes. It's here to create a bridge between them. So what Shredder will do, it will take rstan and VRMS fit objects, create smaller versions of them, and then feed those into tidybayes for some tasks that needs to be done. It can also be extended to different classes other than rstan and VRMS because Shredder is built on S3 methods. So you can attach different classes at any time and extend the package to your needs. In summary, I introduced a new API through Shredder that has new verbs to apply to fit objects in order to return smaller, more efficient, and task-specific fit objects. A new workflow that you can plan more efficiently what post-processing you want to do, and reduce the memory burden based on the smaller fit objects. Because you can bundle the different Shredder functions together and make them model agnostic, this becomes a scalable workflow. So you can compare across different models based on model characteristic or different data inputs. And finally, Shredder is extendable. So any developer can add their own class of input, and Shredder should be able to accommodate their needs. Thank you for listening. This has been Shredder, where Stan models get sliced. You can find the package on GitHub at yannicd/shredder. Thank you.